Hello my dear students, welcome to eCareerPoint-English Medium YouTube channel. So as you know, we are about to complete this chapter, Motion in One Dimension. Today's is lecture 8. If you haven't watched the previous lecture, I suggest you to watch those lectures because they are beneficial to understand this lecture. Okay, so in previous class we have discussed about the relative motion, and in today's class we will discuss about the graphs of velocity time graph, displacement time graph and acceleration time graph, and how to get required information from that. Okay, that will be our today's aim. Okay, so before starting the lecture, let me again introduce to our toppers. These 4 students who were regular e-learning classroom students, they have secured under 50 rank this year. Okay, so this is a great success of our app. As you know about our app, this eCareerPoint learning app, this is very beneficial app for this duration of COVID, because you can learn at your home only with topmost faculties. Hello Asraful. So if you do not have this app, I suggest you to download right now, because see, first of all, how to download this app? Go to Google Play Store, okay, and type here eCareerPoint without any space, eCareerPoint learning app, and just install it. Okay, you will be required to register it. Registration is totally free, so just register it and follow your experts. If you follow your experts, you will be able to attempt the questions posted by your expert, and this is also free of cost. Okay, and if you want the notes of this lecture, all the lectures which we are teaching on YouTube, you can go here, free stuff. In this free stuff, you will see this window. Okay, just scroll down. First of all, select medical section, because I am taking class in medical, so you will see my class and my class notes in this medical section. Okay, so just select this medical and scroll down. Okay, and you will find this class 11 physics NEET 2020 English medium. Okay, in this section you will find this chapter, Motion in One Dimension, and if you click this, you will get all the previous lectures along with notes. In PDF format, you will get all these slides from here. Okay, so quickly share this session, invite all of your friends so that all of them can take benefit of this Kota classes. Okay, and one more thing, we have both paid course and free courses on our app. So if you want to purchase any paid course, here is 10% discount for you. This ST10 is the coupon code to get 10% discount on any purchase on this eCareerPoint learning app. So this is an amazing app. You will get both free stuff and paid stuff. So quickly download this because it is very beneficial for you. So let's start today's class without any delay. So because today we are going to discuss about the graphs used in motion in 1D, like displacement time graph, velocity time graph, acceleration time graph, and how to get required information from the graph. So to learn this, we need the concepts of straight line equation. So let us have a quick revision of the straight line equation. How to draw straight line if we have the given equation, and how to write equation if you have a straight line on the graph. Okay, so see this. See this, y is equals to mx. This is the equation of straight line. This is the equation of straight line passing through the origin. Okay, where m is equals to tan theta. Okay, m is equals to tan theta. And what is theta? Theta is the angle made by this line from x-axis in anti-clockwise direction. Okay, this is theta. Okay, what is the equation of both these lines? Both these straight lines, they are passing through origin. See, this is origin and this is also origin. Okay, So these lines are passing through origin. So what is their equation? Their equation is y equals to mx, where m is equals to tan theta, and theta is the angle made by this line from x-axis in anti-clockwise direction. Remember, in anti-clockwise direction. That is why if we draw this line, we have to measure from x-axis again in anti-clockwise direction. Okay, so tan theta is m, and m is also known as slope. Okay, so y is equals to slope multiplied by x is the equation of straight line passing through origin. Okay, this thing you should remember. Although this is the topic of mathematics, but it is required in physics. That is why I am taking this quick session of equation of straight line. So this is how we can draw a straight line. But we know we have so many lines which do not pass through origin. Also, in your previous classes, you have discussed about drawing straight lines if you know the equation. And the process was you were drawing a straight line by writing the coordinates. Okay, so that is a lengthy method. You should know this short method. Okay, one more thing. This theta can vary from 0 to any angle. Okay, so this slope can be positive or can be negative. If you see this, the value of tan theta when theta is having so many angles, then as you can see, from 0 to 90 degree, from 0 to 90 degree, this tan theta is positive. Okay, and at 90 degree, this tan theta tends to positive infinite, so it is also known as not defined value. Now, after 90 degree till 180 degree, as you can see, the tan theta is negative. Tan theta is negative from 90 to 180 degree because tan theta is positive in first quadrant and in third quadrant. That means if theta is between 0 to 90, the slope will be positive. If theta is between 90 to 180, the slope will be negative. Again, if theta is between 180 to 270, the slope will be positive, and after 270, the slope will be negative. Is it clear? So this thing you should remember, that the value of slope can be positive or can be negative. Okay, so this is the general equation of straight line. It is not necessary that our straight line will pass through origin. Okay, straight line passing through origin is y equals to mx. But if it is not passing through origin, the equation will be y equals to mx plus c. Okay, where this c is y intercept. Okay, this m is slope, which is tan theta, and theta, you already know, theta is the angle made by this straight line from x-axis in anti-clockwise direction. Okay, from positive x-axis. Now, what is this c? The c is known as y-intercept. What is the meaning of y-intercept? The point on y-axis where this line will cut the y-axis. Okay, see, this line is cutting the y-axis. So the y-coordinate at the point of intersection of y-axis and the line is known as y-intercept, and this is the value of c. So, see, from origin to this point, this length is equals to c. Okay, for example, here, see, here, this is the y-intercept. What is y-intercept? The point on y-axis where the straight line is cutting the y-axis. This is known as y-intercept. Okay, and definitely the y-coordinate where the line is cutting the y-axis is known as the y-intercept c. Here also, as you can see, because it is cutting the y-axis in positive y part, so again c is positive here and here. But look at this graph. This graph is cutting y-axis in its negative part. So the y-coordinate where the graph is cutting this axis will be negative. That is why c is negative in this case. Okay, so both m and c can be positive or they can be negative. Okay, for example, see, if I take equation y is equals to under root 3x plus 7, this is the equation of straight line. Okay, this is the equation of straight line because this is similar to this equation. Okay, this is the equation of straight line. equation of, this is general equation of straight line. If the line passed to origin, in that case the y coordinate where the line is cutting y-axis will be 0, so this c will be 0. That is why we were having y equals to mx, that was the straight line passing through origin, because the value of c is 0 in that case. Okay. Now see, if I ask you, look at this equation and give me the value of m and c, think what will be the values. This is the equation of straight line and we are going to draw this straight line. So what will be the value of slope and what will be the value of this y-intercept? Think. So what we are going to do, just compare this equation with this general equation. This is the general equation. If you compare, you will get this under root 3 is equals to the slope m, and this y-intercept c is equals to 7. So for this equation, m is equals to under root 3, which is equals to tan theta. So from here we will get theta is equals to 60 degree and c is equals to 7. Yes, Himal, very good. So theta is 60 degree. That means this straight line will make 60 degree in anti-clockwise direction from this x-axis. And it will cut the y-axis at a distance of 7 in positive y direction. Okay. So if we want its graph will be like this. This is x, this is y. Y-intercept is 7. That means this graph is going to cut y-axis at y coordinate 7. That means this coordinate will be 0, 7. At this point, the graph will cut and it will make 60 degree in anti-clockwise direction from x-axis. So graph will be like this. And this theta will be equals to 60 degree. So this is how we are going to draw the graph if we know the equation. And it is very simple, very, very, very simple. Okay. If I take another example, y is equals to minus x plus 3. What will be the values of slope and the y-intercept? What is the value of m and c? First of all, to find out this equation can also be written like this. See, I can write this equation like this also. Y equals to 3 minus x. Minus 3 plus x or 3 minus x, both are same. So just find out the value of m and c to draw the graph of this line. See, drawing graph is very much necessary for this lecture because we are going to use these graphs in physics. So if you compare, you will get m, which is equals to slope, which is also tan theta, is equals to minus 1. Okay, that means tan theta is equals to minus 1. So theta is equals to 135 degrees. And what is the value of c? C is equals to 3. Okay, so its graph will be like this. See, this is y-axis, this is x-axis. Now, theta is 135 degree and the point on y-axis or the distance where it will cut the y-axis is equals to 3. That means it will cut the y-axis at this point 0, 3. And it will make 135 degree in anti-clockwise direction from x-axis. So graph will be like this. Okay. Clear? So it is very simple. Now, if I ask you to draw the graph of y equals to minus x, what are the values of m and c? In this case, m will be equals to minus 1 and c is equals to 0. So the graph of this equation will pass through origin. See, graph of this equation will pass through origin. Why? Because the value of C is 0. And what is C? C is the y coordinate on the y-axis. C is the point on y-axis. C is actually the y coordinate of a point on y-axis where the graph is going to cut the y-axis. So it is equals to 0. That means the graph will pass through origin. The graph will pass through origin. And it will make, this implies tan theta is equals to -1. This implies theta is equals to 135 degree. So the graph will be like this. This is the graph of y equals to -x. Okay. What is this, Sanjay? Pi. I think this typing mistake in your comment. See, another example that you are going to tell me. Take y is equals to under root 3x minus 2. What is the value of m and what is the value of c? And try to draw graph by yourself. Find out the slope and the y-intercept. See, this is the equation of straight line. If you get x square or x cube, that is not straight line. That will be a curved graph. So in this question, as you can see, if you compare this equation with this equation, y equals to mx plus c, you will get m is equals to under root 3. That means tan theta is under root 3. So theta is equals to 60 degree. Okay. And value of c is equals to -2. Value of c is -2. What does it mean? This is x-axis, this is y-axis, and this is origin. Now, we got the value of theta. That means the graph will make what angle? 60 degree angle from the x-axis, and its y-intercept is -2. That means it will cut the y-axis where the y-coordinate is -2. So the y-coordinate is -2 at suppose this point, and its coordinate will be 0, -2. So the graph will pass through this point and it will make angle 60 degree from the x-axis. So this will be the graph. Okay, this theta is equals to 60 degree. So I think that is enough. Good, Himal. Yes, you are right. I think that is enough to understand the equation of straight line. Although, as I told you, this is the topic of mathematics, but it is required in physics. That is why I have taken some examples. So let us start with the physics part. Okay, that is required. That is our actual today's lecture. Graphical representation of one dimension motion. Okay, we are going to draw the graph of any motion given. Okay, and there are different kind of graphs. So let us start with the situation of constant velocity. What will be the graphs of constant velocity? See, first of all, velocity is constant. That means acceleration is 0. Okay, velocity is constant. That means acceleration is 0. Now, if we want to draw the graph of velocity time graph, suppose if we want to draw velocity time graph, it will be a straight line parallel to the time axis, because velocity is constant. That means velocity will not change as the passage of time. See, when time was 0, the velocity was having this value. Suppose it is 5 meter per second. Okay, example, velocity is 5 meter per second. So after 2 seconds, it is again 5. After 3 seconds, it is again 5. So velocity is constant. That means the graph will be a straight line parallel to time axis. Okay. Why? Because see, we write the equation like this. we have to convert this in v. V instead of y and t instead of x. So its graph, if I say velocity is equals to 5 meter per second. So what is the slope? Compare this equation with this equation, y equals to mx plus c. Remember, x we draw here, y we draw here. So in this example, m is equals to 0 because v is not dependent on time and c is equals to 5. So this is a straight line passing through this point 0, 5, and it is its angle from the x-axis is 0. Okay, this is how we are going to draw graph. We know the equation, we have drawn the graph. Okay, now if we talk about the xt graph, suppose particle is moving in x direction, so its x coordinate will be the x coordinate will be the displacement. Okay, and one more information I am giving, at time 0 x was also 0. So because velocity is constant, so I can say this x coordinate, see the particle is moving in this direction, x direction. Okay, this is y direction. These are the coordinates, x, y coordinates, and I am going to draw the graph with respect to time. So suppose particle was here initially, okay, and this particle is moving in this direction with a velocity 5 meter per second. So its velocity time graph is a straight line, but if I want its x coordinate, then at any time t. So because velocity is constant, I can say that its x coordinate, that is the displacement, is equals to v into t. So now compare this equation. Right now I'm going to draw the x in this part because I want displacement time graph. Okay, so don't get confused with this x and this x axis. This x is representing the displacement. So here also c is equals to 0. That is why this graph is passing through the origin. And slope is equals to v. Okay, this theta, tan theta is equals to v. Clear? Yes, Himal, very good. So this is for constant velocity, velocity time graph, and this is displacement time graph. Don't get confused with this x and this x axis. On x axis we are taking time, and this is x coordinate which is equals to displacement. So this is displacement time graph. Compare this equation. This is y, this is m, this is x, and c is equals to 0. Simple. Okay. Now let us draw the graph for constant acceleration. Suppose acceleration is constant and it is positive. Acceleration is positive. That means acceleration is in the direction of initial velocity. Okay. Or we can say acceleration is in the direction of the chosen positive x-axis. That is more correct. Now, if acceleration is constant, acceleration time graph will be like this. A straight line parallel to time axis. Why? Because acceleration is not changing. Okay. Acceleration is constant. Okay, if I say example, acceleration is 2 meter per second square. So here compare this equation with y equals to mx plus c. Y is acceleration, x is time in this example, and c is the y-intercept. So this value will be 2. Okay, and here m is equals to 0 and c is equals to 2. So this is again straight line which is parallel to time axis, making angle 0 from x-axis and passing with this point 0, 2. Okay. Now if acceleration is constant and I want velocity time graph, what can I do? When acceleration is constant, listen, when acceleration is constant, then we can apply those equation of motion that we have derived. So if acceleration is constant, we can write v is equals to u plus at. V is equals to u plus at. Now again, to draw the velocity time graph, compare this equation with y equals to mx plus c. And you will get that m is equals to a. Okay, this equation is for VT graph. If you want velocity time graph, see, slope will be equals to a and c will be equals to u. So if we want to draw the velocity time graph, it will be like this. Velocity time graph will pass through origin if zero initial velocity is there. See, if u becomes 0, equation will become y equals to mx. So it will pass through origin if velocity initial is 0. Okay. Similarly, if I take positive initial velocity means c intercept must be positive. So graph will make, see, if this is theta, then tan theta is equals to acceleration. Simply compare this equation with this equation of straight line. Okay, we have two variables v and t. Similarly, we will having variable y and x. So v instead of y and t instead of x. That is why a is equals to m and c is equals to u. So slope of velocity time graph is actually acceleration. Okay, and slope of displacement time graph was velocity. So if initial velocity is positive, if u is positive, that means c is there, c is positive. So graph will be like this. It will cut the velocity axis at the point 0 comma u. That means this is the initial value of u. Okay, this is initial velocity simply. See, at time t equals to 0, initial velocity is u. At time t equals to 0, its velocity was 0. Now, if we have initial negative velocity, so graph will start from here. But it is making angle theta and tan theta is equals to acceleration. Again, it is making angle theta and tan theta is equals to acceleration. But in this step, the initial velocity was positive, and here initial velocity is negative, as you can see. And this is the slope. If c becomes negative, at time 0, velocity will be negative. Okay. Let us just refresh your internet connection if you are not getting the clear quality. Okay, this may be the internet issue from your side. Now, see, displacement, which is x, it will be ut plus half at square. Displacement, if I talk about displacement, if I take displacement as x, okay, so this is the displacement if u is equals to 0. Okay, so this is the displacement time graph because this is the equation of parabola. Now, for negative acceleration, suppose acceleration is negative, then what will be the graphs? If acceleration is negative, then acceleration time graph will be this. Suppose acceleration is minus 2 meter per second. Then for this equation, slope is equals to 0 and c is equals to minus 2. So graph will be like this, making angle 0 from the time axis and passing through this value, minus 2 meter per second. So this is the acceleration time graph if a is negative. And this is velocity time graph. See, velocity v is equals to u plus at. Okay, or we can write v is equals to at plus u for better understanding. Compare this equation with y equals to mx plus c. M is equals to again a and c is equals to u. Okay, so the graph will be like this. If, see, as I told you, if angle is greater than 90 degree, this will be theta in this case. If angle is greater than 90 degree, that means tan theta is negative. And because acceleration is negative, slope is negative, that means this theta will be greater than 90 degree. That is why we are having graph like this. Okay, remember always tan theta is positive for 0 to 90 and negative for 90 to 180 degrees. So because this acceleration is negative in this equation, y equals to mx plus c, this m, which is acceleration, is negative. So we have angle greater than 90 degree. And this is for zero initial velocity. That means graph is passing through the origin. Zero initial velocity means c equals to 0. So graph is passing through origin. Okay. Then for positive initial velocity means the graph will shift upward. Okay, the slope will remain same, the angle from x-axis remains same, time axis, but the y-intercept is now positive because c was the initial velocity in this case. Okay, this is the equation for VT graph. Similarly, if we have negative initial velocity, the graph will start from here. As you can see, because acceleration is negative, so velocity is continuously decreasing. If 0 is the initial velocity, it is continuously decreasing. If positive initial velocity is there, it is continuously decreasing. And if negative is there, again decreasing. Okay? Clear? So this is how we are going to draw the graph. If you know the equation of straight line, you will be able to draw the straight line graphs. Okay, now let us study how to find different parameters if we have any given graph. And this is amazing technique to solve the question graphically. So this is very important. Pay attention. See, if we talk about position time graph, what is position time graph? It is xt graph. That means x, if particle is moving along x-axis, then its x coordinate with respect to time graph is this xt graph. So with position time graph, which information we can get? See, suppose we are having these 2 points. Suppose this is position time graph, which is not a straight line. We have studied the equation of straight line. Suppose this is position time graph. So from this position time graph, if this is point A and this is point B, okay, the particle is moving along x-axis and actually it is moving like this, and we are drawing the graph with respect to time. So if we are having 2 points A and B, and suppose these are 2 points. At point A, the time was t1 and the x coordinate was x1. At point C, these all are the cases of motion in one dimension. That means along only one axis. And at time t2, suppose coordinate is x2. If I want the average velocity between point A and B, what will I do? Total displacement by total time is average velocity. That means if I join these 2 points AB and make this triangle, okay, then this length of the triangle will be x2 minus x1, and this distance will be the time difference t2 minus t1. So if this is the angle theta, if I take this angle theta, see, this is angle theta. What is delta x? Delta x is x2 minus x1 and delta t is t2 minus t1. So average velocity is equals to x2 minus x1 upon t2 minus t1. That we already know. But with this graph, how can we use this information? See, slope of chord. What is chord? Chord is a line passing through 2 points of any given curves. That means if we want average velocity between point A and B, what will we do? We will draw this line AB. And slope of this chord, this AB is the chord. Slope of the chord between any 2 points on the position time graph gives average velocity between these 2 points. See, this is a good information that if we have this graph, position time graph, and we want average velocities between any 2 points, what we are going to do? We are going to join these 2 points by a straight line, and the slope of that straight line, that is a chord, will give you the average velocity. See, slope is equal to tan theta, which is x2 minus x1 upon t2 minus t1, and this tan theta is average velocity. See, if this is theta, then tan theta is average velocity. Now, if we want instantaneous velocity, what we are going to do? Instead of drawing chord, we will draw a tangent. There is a difference between chord and tangent. Chord means a line passing through this curve, cutting the curve at 2 points. And what is tangent? Tangent is a line which is passing, just touching the axis, just touching the curve at any one point. So see, instantaneous velocity means velocity at a particular instant, and average velocity means average velocity between two given points. So we were having 2 points and 1 point for instantaneous velocity. So if we have displacement time graph, and if we want instantaneous velocity at any given point, suppose I want instantaneous velocity at this given point, what will I do? I will draw a tangent. Tangent is a straight line which is just passing, touching this curve. I will draw this tangent, and now tangent tan theta will give me instantaneous velocity. Okay, so here tan theta was giving average velocity, here tan theta is giving instantaneous velocity, because here we have chord passing through 2 points, here we have tangent which is passing through any 1 point. Okay, we can assume that for a small part of curve, the tangent and curve are overlapping. Okay, this is the small part where tangent and curve are overlapping, very small part, as small as the thickness of paper. So if this is theta, then in that small part, suppose this is small displacement and this is small time interval. So tan theta is ds by dt, which is instantaneous velocity. Okay, so these two statements you should learn, that slope of chord between 2 points gives average velocity, slope of tangent at any 1 point gives the instantaneous velocity, and these are valid for position time graph. Okay, so these are position time graphs. If we have position time graph, slope of chord at any 2 points will give you average velocity, and slope at any slope of tangent passing through any 1 point will give you instantaneous velocity at that point. Okay, this information is very, very, very important. Okay, now see, the displacement time graph of a particle is shown in the figure. Okay, this is displacement axis, this is time axis, and this is displacement time graph. What you have to do, find the instantaneous velocity at t equals to 20 seconds. At t equals to 20 seconds, find the instantaneous velocity. How you are going to find that velocity? But there is no problem from our side. Just refresh your, just check your internet connection and refresh this page. See, this is t equals to 20 seconds, and at t equals to 20 seconds, the point on the graph is this, and we have to find the instantaneous velocity. What was the rule to find instantaneous velocity from the graphical method? Draw the tangent at this point, because this is a straight line, so tangent at this point will be the same straight line, and slope of this tangent will give you the instantaneous velocity. So it is easy to find slope. If this is tan theta, see, first of all, we have to draw a tangent at this point, because this is a straight line, so tangent will be the same straight line. Now slope of this tangent is equals to tan theta. If we can calculate tan theta, that will be the instantaneous velocity at t equals to 20 seconds. Okay, now see how we can calculate tan theta. We have this triangle. We have this triangle, and in this triangle, what is the perpendicular? It is 2 minus 1, which is 1. And what is the base? Base is 30 minus 20, that is 10. So tan theta is equals to, we can say 2 minus 1 upon 30 minus 20. So velocity, instantaneous velocity, which is tan theta of the tangent passing at any given point, is equals to 1 by 10. So velocity is equals to 0.1 meter per second. Hence answer is option A. See, no integration required, no differentiation required. We are just observing the graph and we are calculating the required information. So the graphical questions, they are very easy. If you know the definitions, how to find out the information from graph, the graphical questions are very, very, very easy. Good, Himal, you're right. Good. Now, see this. Next question. A particle shows distance time curve as given in the figure. This is the distance time curve. And you know, if particle is moving in a straight line without changing its direction, then distance is equals to displacement. So this can also be treated as displacement time graph if motion is one dimension without changing direction. Then it is asking the maximum velocity of the particle is around the point. Okay, we have several points. Suppose this is point A, this is point B, this is point C, and this is point D. As you can see, it is asking at which point we are having maximum velocity. That means it is talking about instantaneous velocity, and you know how to find instantaneous velocity. To find instantaneous velocity, draw the tangent at given point and find out the slope of that tangent. So see this. If I draw the tangent at point A, it will be like this. If I draw the tangent at point B, it will be like this. If I draw the tangent at point C, it will be like this. If I draw the tangent at point D, it will be like this. So which point tangent is having maximum angle between 0 to 90 degree? That will be the answer. Because you know, from theta 0 to 90 degree, if theta increases, tan theta also increases. Okay, between 0 to 90 degree, if theta increases, tan theta also increases. Okay, so as you can see, this is theta A, this is theta B, this is theta C, and this is theta D. Out of which point the tan theta will be maximum? Think. Good, Himal, you're right. Well done. Out of which point the tan theta is maximum? See. Maximum slope. Slope of tangent at any point on position time graph or displacement time graph gives you the instantaneous velocity, because the slope is maximum for point C. Slope is maximum for point C. That is why answer will be option C. Okay. So it is very simple. Good, Abhishek Kumar, you are also right. Well done. So beta, quickly share this session to all of your friends so that everyone can take the benefit of this Kota coaching classes. And these kind of question, the competition ask. These kind of question are asked in the competitive exam, so they are very simple. Now, next question. The displacement time graph of a moving particle is shown below. Okay, and because we are studying the motion in one dimension, so motion is in one dimension. Okay, the instantaneous velocity of the particle is negative at which of the following points? C, D, E, or F? At which point among C, D, E, F the particle is having negative velocity? So because this is position time graph, we know that slope at any point will give us the velocity. And what is slope? It is tan theta, and theta is the angle measured by the slope, the tangent from the x-axis, and here x-axis is the time axis. So you have to see at which point the tan theta is negative. As I told you, for theta greater than 0 less than 90 degree, tan theta is positive. For theta greater than 90 degree but less than 180 degree, tan theta is negative. This is the basic conclusion from the trigonometric ratios. Okay. See, if you want to give the answer, write option A, option B, option C, or option C or D. Okay, because there is C which is in the option A, and there is option C which says E is correct. Okay, so write your answer like option A, option B, option C, or option D in this particular question. Okay, so say this. Let us solve this at point C. As you can see, this is the slope and this is theta C. At point D, theta D is equals to 0 because it is not making any angle from the time axis. At point E, the angle theta E is greater than 90 degree. This is less than 90 degree. And at point F, this theta F is what? Less than 90 degree. Okay, so tan theta E is negative. So at point E, velocity is negative. Okay, so answer is option C, which says E is correct. Okay. Good, Abhishek and Himal, very good. You have given the correct answer. Well done. So physics is very easy. If you study step by step, you will feel physics is very easy. Okay. Now let us talk about the velocity time graph. Velocity time graph. See, the slope of chord between any 2 points on the velocity time graph gives us acceleration. See, what is average acceleration? If a particle is moving in straight line, so between points A and B, if we have velocity time graph, then if I join A and B, then if I make this triangle, this length will be the change in velocity, and this length will be the time taken to change this velocity. Okay, see, this is the velocity time graph, and if I want average acceleration between points A and B, what is the definition of average acceleration? Change in velocity upon change in upon time taken to change the velocity. Okay, this is average acceleration. So if I draw a chord means a line, straight line, which is passing through in such a way that it is cutting the graph at 2 points. So if I draw a chord between points A and B, the slope of that chord will give us the average acceleration. Okay, see, this is the theta. If I draw this triangle here, this is the theta, this is change in velocity, this is time taken to change this velocity. So average acceleration is tan theta. Okay, is tan theta because it is perpendicular to the base, it is delta V by delta t. So slope of chord between any 2 points on velocity time graph gives us average acceleration. Okay, slope of velocity time graph gives acceleration, and slope of displacement time graph gives velocity. That you should remember. And if I want instantaneous acceleration, that means acceleration at any particular point, then if I draw the tangent at any point, then slope of this tangent will give you instantaneous acceleration. Okay, similar thing. Yes. So if I assume that there is a small part which is overlapped by this tangent on this curve, this small part is this, and because it is small, in this small part the change in velocity is small, that is dv, and the time taken to change this velocity is very small, dt. So tan theta will be dv by dt, and what is dv by dt? Dv by dt is instantaneous acceleration. Yes, Abhishek, you are right. Okay. So it is very simple. Area under velocity time graph gives the displacement with sign and distance without sign. Okay. See, as you know, in integration, I told you what is integration. Definite integration means area under the curve. So if we are having velocity time graph, then area under the curve between two given points of time will give us the displacement. Displacement is also known as change in position in that given time interval. Okay, Abhishek? So it is very important that slope is giving us acceleration. Slope of VT graph gives us acceleration, and area under VT graph gives us displacement. If we add the area with sign, we will get displacement. If we add the area without considering the sign, we will get distance. Now, yes, because integration of velocity gives displacement, and integration physical graphical meaning is area under the curve. So area under the curve will also give the displacement. That is the logic. So to understand this better, let us take an example. See, we have a velocity time graph. From 0 to 2 seconds, velocity was 4 meter per second. From 2 to 4 seconds, velocity was minus 2 meter per second. That means in opposite direction. And from 4 to 6 seconds, velocity is again plus 2 meter per second. So what we have to do, we have to find displacement and distance traveled by this body in 6 seconds from starting. So we are going to use that definitions. First of all, let us calculate the area. See, this area, what is the value of this area? Suppose this is area A1. So area A1, because it is rectangle, so this area is 2 into 4, that is 8. And remember, the area which is above this x-axis is positive and area which is below the x-axis is negative. So this area A2, if I want to calculate, A2 will be equals to this length, which is 2, into breadth, which is minus 2. So 2 into minus 2, it is minus 4. This area is 8, this area is minus 4. And suppose this is area A3. So what will be the value of this area? This area A3 is length, which is 2, and breadth, which is also 2. So 2 into 2, it is equals to 4. As you can see, the upward area is positive and downward area is negative. So if we add these area with sign, we will get displacement, and if we add these area without sign, we will get the distance. So displacement is area under VT graph with sign. So it is equals to A1 plus A2 plus A3, which is equals to 8 minus 4 plus 4. So it is equals to 8. Displacement is 8 meter, and distance is equals to area under VT graph. Area under VT graph without sign. That means it is equals to mod of A1 plus mod of A2 plus mod of A3, which is equals to 8 plus 4 plus 4, and this is equals to 16. So displacement is 8, distance is 16, and it is asking displacement and distance respectively. So answer is option D. Is it clear to all of you? Good. Ahimal, Abhishek, very good. So see, this is very simple. Okay. Now see, The adjoining curve represents the velocity time graph of a particle. Okay, its acceleration values along OA, AB and BC in meter per second square are. As you know, this is velocity time graph. So slope of VT time graph will give you the acceleration, because it is asking the average acceleration between OA, AB and BC. So from O to A, this is suppose theta 1. Okay, so acceleration from O to A is equals to tan theta 1, and as you can see, the slope from A to B is 0 because it is parallel to time axis. So acceleration at AB will be equals to tan 0 because theta 2 is 0. Now suppose this is theta 3 and this is theta 4 or theta 3 dash, we can say. So acceleration at B to C is equals to tan theta 3, which is also equals to negative of tan theta 3 dash. If you are taking this angle, then slope will be tan theta. If you are taking this angle, slope will be negative of tan theta. Okay, so this you should remember, because tan 180 minus theta is minus tan theta. Now let us calculate. Yes, Himal, you are right. Well done. So for OA, what is tan theta 1? It is perpendicular by base 10 upon 10. So it is equals to 1 meter per second square. Tan 0 is 0 meter per second square. And this from B to C, because we can calculate tan theta 3 easily because we have this triangle. So we will use this value, negative of tan theta 3. And what is tan theta 3? It is perpendicular by base, that is 10 by 40 minus 20 is 20. So 10 by negative of 10 by 20, which is equals to minus 0.5 meter per second square. So accelerations are 1, 0 and minus 0.5 meter per second square. Answer is option 1. Is it clear to all of you? Okay. So that is enough for today. In next class, we will continue this part, some part of graph and some miscellaneous questions. And after that, I will take a Menti quiz. Yes, an online quiz. So stay tuned, subscribe this channel if you are new, and download eCareerPoint Learning app. Okay. If you subscribe this channel and press the bell icon, you will get the notifications of upcoming amazing lectures and quizzes. Okay. So this is Sumit Talwani signing out. Thank you very much. You're welcome, Abhishek.